you very much. It looks like we got a great turnout for today's discussions, presentations. Are we going to turn off these overhead lights up here? Can we maybe highlight the screen a little bit? Thank you. Let me point out that the asterisk next to the naked age, it's not my original wording. It came from a book that was printed by, published by, authored by Desmond Morris back in 1967. Discussing the fact that we as a human, we as an ape, lost our hair so many millions of years ago, and so thus we are a naked ape. The picture on the far left is of a strange chimpanzee that's in a zoo. I think its name is Ashes, if you wanted to look it up online. That is also a hairless ape, so I just threw that up there for fun. Well, we are going to talk about hominid evolution, but before we do, let me give you some vocabulary, I guess. For the last few decades, the term hominid has referred to a group, taxonomic designation referring to basically us as humans and our nearest ancestors, australopithecines and some of the fossil evidence that we're going to be talking about today. But in essence, taxonomically, we're talking about the hominoid family, or excuse me, Hominoideae superfamily, which includes everybody up on this list. The lesser apes, the gibbons and siamangs, the orangutans, gorillas, chimpanzees, and I couldn't fit a picture of bonobos in there, but they're also another type of ape under Pan. Homo sapiens, and our hominid ancestors, our australopithecines, etc. Recently, though, there's been some discussion within the field of paleoanthropology as to how to treat the connection between humans and chimpanzees, both genetic and fossil evidence, suggesting that they, the genetic evidence shows that chimpanzees are more closely related to humans than they are to their other ape cousins, the gorillas. So there's some interesting discussion in there. And since basically my training was under the hominid naming of this category, I will refer to these creatures today as hominids. I refer to myself as a hominid, so to say, instead of hominid. I'm not used to saying that word yet. So forgive me for those of you in the audience who are working with that taxonomic designation. Okay, just to give you a brief synopsis of what was going on before 7 million years ago, to give you a little bit of evolutionary perspective, we can start, the discussion kind of could go back to the earliest stages of mammals, or when they took over, roughly around 65 million years ago after the dinosaurs went extinct. Some early primate-like mammals started to evolve, quadrupedal, somewhat omnivorous, meaning eating about anything, living up in the trees, some nocturnal, some diurnal. At around 50 million years ago, we see in the fossil evidence of the first true primates, those that are showing the earliest forms of a primate traits, and that's not the discussion we want to get into today, so I won't go into detail there. 45 million years ago, the anthropoid form starts to develop, representing what essentially is the monkey form, the traditional monkey form. And so I've got, spinning off of this line, New World monkeys starting to develop around this period of time in Central and South America. We've got Old World monkeys come into the picture here in Africa and Asia. And around 20 million years ago, we start to see the evolution of the ape form. Around the Miocene, the tailless ape coming down to the ground, residing on the ground, terrestrial-like locomotion for a period of time, and then returning to the trees during the evening. Finally, at around 6 to 8 million years ago, and we like to work in ranges, so some people say 5 to 7 million years ago, 6 to 8 million years ago, but roughly at around 7 million years ago, we've got that split from our nearest common ancestor, and that's where we're taking off with today. So to follow along with that chart, going to that last split there, 7 million years ago, the discussion we're going to focus on is how, if you go back, this line leads up to the chimps and bonobos actually split up, but this split right here is represented by this split going up to the chimp line right there. So we're going to focus on the fossil evidence that traces the hominid line all the way up until modern Homo sapiens at the other end. So what's going on in Africa some 7 million years ago? Massive climate change. The jungles across Africa are reducing in population density, in the sense of jungle growth is reducing, jungle dimensions are reducing. tropical landscape is decreasing in size. What is increasing or what is taking over are large open grasslands. So it's producing this massive competition, struggle for existence, an adapt or die type of scenario. If you can't survive in the jungles, then you're going to have to figure it out somewhere else. And those early ancestors of ours made a life for themselves out on the open savanna. At around this point in time, getting now more to the fossil evidence, we find some, they have discovered some fossil evidence dating back to around 7 million years ago. This is the species right here. I brought in some plastic casts of these. None of these are real. But representing this species named Sahelanthropus shadensis, dating back to roughly around 7 million years ago. Most likely, or possibly, the link between chimpanzees and early humans, suggesting that this may be that missing link, our common ancestor. Well, I'm kind of tracking this in somewhat of a historic sense, and even though the Chad discovery was found roughly about maybe 10 years ago by now or so. In 1871, Darwin made this fantastic prediction that he wrote in his book called The Descent of Man, and if you'll allow me, he says, "I say, old chap, in each great region of the world, the living mammals are closely related to the extinct species of the same region." It's better I talk in the accent so I won't screw it up. "It is therefore probable that Africa was formerly inhabited by extinct apes closely aligned to the gorilla and chimpanzee. And as these two species are now man's nearest allies, it is somewhat more probable that our early progenitors lived on an African continent than elsewhere." Now, let's go get some tea, shall we? So this brave prediction, even though he had not found any of the skeletal evidence yet, he made this rather interesting hypothesis. Well, it took about 50 years later until somebody actually found the evidence that Darwin was suggesting. 1924, an anthropologist by the name of Raymond Dart was doing some, well, it was actually delivered to him, but he gets credit for discovering one of the earliest Australopithecine finds. And this skull, named today as the Tong child, because it represents a small child roughly around 4, 5, 6 years of age. It's this specimen right here, found only with the facial bones, a mandible, and what they call an endocast, or a fossil cast of what the inside of the cranial vault looked like. Showing some rather remarkable features according to Dart. It showed both chimpanzee and human-like features, suggesting that, in his mind, this was truly the missing link. So in the 1920s, the proposal that a missing link existed between humans and apes was evidenced by this fossil discovery, which prompted, of course, more excavations and more discoveries, and not too much longer later, I'm sorry, I'm a little bit nervous actually, they discovered more Africanus remains. The Australopithecus africanus that Dart found was named because of Australopithecus referring to southern ape, Australo referring to southern, like Australia, the southern continent. Pithecus refers to ape, and Africanus being the country from which it came. So like I said, more Africanus remains were eventually discovered. We keep finding more of them in Africa, and the place in Africa we're finding them is a region called the Great Rift Valley, which is essentially Central East Africa. Also others found in South Africa as well. Two rather different climates to be finding these hominid remains in, but again, that's information for another talk. So some of the hominid traits that Dart and paleoanthropologists are observing in these species, again, possess some of the ape-like traits and the human traits. The projecting lower face that we see as an ape-like trait, I probably should have brought a chimpanzee skull in to show you as well, but the chimps have somewhat of a projecting lower face as well, a relatively small brain case in comparison to body size, in comparison to modern humans as well, and relatively larger teeth for the diet that they're chewing on. In contrast, what we also see in these Australopithecine hominid remains is forward-placed foramen magnum. And this hole on the bottom of the skull, you can see it in the black and white image right there. This hole on the bottom of our skull is called the foramen magnum. It's one of the largest foramina in the body. It is the hole from which our brain, our spinal cord comes out of and goes down our backbone. And so the position of this hole on the base of the skull tends to represent where the backbone came out of, or how it's projected off the base of the skull. Quadrupeds, a cow, a horse of some sort, tends to have a foramen magnum more posteriorly placed more on the back of the skull, indicating that the backbone would have come out of the back of the head, and therefore this would have been more of a quadruped. The placement of this hole on the Australopithecines is somewhat intermediate between chimpanzees and humans. Humans have it directly placed underneath the skull, such that if we were to hold the skull in anatomical position, it's almost straight underneath the skull. In Australopithecines, it's not completely straight under, nor is it completely all the way back as a quadruped. It's somewhat more of an oblique angle, suggesting that this creature was a biped, not a habitual biped, not something that walked around on two legs habitually. Probably was perhaps more comfortable sitting down on the ground, perhaps more often than not. Oh, to not go through all of the species of Australopithecines that are out there, they tend to lump them together into two general categories. There are the gracile Australopithecines, like Africanus, the one I'm showing you here. And I'm going to go into the graciles and the robust in just a moment, giving you a brief description of each. But the gracile Australopithecines tend to be somewhat of a smaller version of an Australopithecine, and the robust, of course, as the word suggests, a much larger version. If you were to perhaps picture what these two creatures look like standing in front of you, picture a chimpanzee standing up on two legs and a gorilla standing up on two legs. A rather robust, healthy, they're both going to be well-muscled individuals, but a larger individual in the gorilla, smaller individual in the chimpanzee. So the gracile, smaller form would be the chimp version that I'm describing here. Perhaps like the picture in the upper right for a gracile. Well, one of the more famous gracile Australopithecines that perhaps many of us know if you've studied any of the fossil record is Australopithecus afarensis, found by Donald Johanson in the early 1970s. This was a rather fantastic find, only because they found almost the complete skeleton of this species, represented by this diagram off to the far right. Spectacular in the sense that so many bones were found from one individual. It's very difficult to find that. Quite often we find very little. So to see so much of an entire skeleton from one person, from one individual, can tell us much about the species and life. The name Lucy, that she's often referred to, and she was a female skeleton. Johanson and his colleagues, when they found the bones that afternoon, took it back to the camp. They knew they had this fantastic specimen. It was dated roughly to about 3.5 million years ago. It was the oldest one found yet, older than Darts africanus, older than anything that had been out there. And so Johanson was thinking that, oh my God, we got the coolest missing link ever. Mind you, Charensis wasn't found until, like I just said, the 1990s or something. So in the 1970s, this was, Johanson made the cover of Time and Newsweek and all the fancy journals out there with his publications. But that night at the camp, they were playing music as they were examining the remains. They knew she was a female skeleton, but they had the Beatles' Sgt. Pepper's Lonely Hearts Club Band album playing, and Lucy in the Sky with Diamonds was the song playing most often. And so as a female skeleton, and perhaps with a little bit too much intoxication, they decided to name her Lucy, and the name is stuck. And so often when you see some of these types of films or documentaries on afarensis, they often refer to as Lucy, even though they may be talking about male skeletons as well. So Lucy was found here, Lucy did this, Lucy did that. Some other remarkable bits of evidence that help us to determine that afarensis, or the hominids walking around, living at 3.5 million years ago, were actually walking around on two legs, were some footprints. Placed into wet volcanic soil, again, some 3.5 million years ago. These found at a site in Laetoli in Central East Africa show distinct bipedal footprints of a creature living at this time. And Lucy found not too far away in the Olduvai Gorge. These at the site of Lake Tolly suggest that, yes, the species that made these footprints was Afarensis. What's of course also intriguing is that there are other animal species that are walking across this, antelope, birds, etc. And they've made some rather romantic reconstructions of what this could represent, because one of the lines of footprints is a rather large one and one's a rather small one. The more romantic visions you might see in the museum reconstructions. I think the one on the right is a New York museum. But of an adult male and an adult female walking arm in arm, all lovey-dovey as they're watching the beautiful sunset as the volcanic dust starts to settle. Or, you know, female behind the male, whatever that might represent. My own personal interpretation, having kids myself, that they often lag behind as you're walking, is perhaps it's an adult male and a juvenile walking behind, or not an adult male, but an adult and a child walking behind. Who knows? But either way, the footprints themselves show a foot that is remarkably similar to the modern Homo sapien footprint we have ourselves. So Afarensis is classified as a gracile Australopithecine. Boisei and Robustus, this larger form right here, is classified as a robust Australopithecine, much larger in features. And again, I think I'm relatively pressed for time, so I won't get into too much of the detail as to how and why these features may have evolved. But according to these features, we can determine much about lifestyle and behavior that these creatures had. I keep calling them creatures. They're our ancestors, animals, humans, whatever you want to call them. Environment in which they're being found, bushland and open savanna, presumably social. That conclusion kind of comes from looking at the fossil evidence, the paleoanthro evidence, coupled with primatological evidence as well, looking at how the features that we see in modern-day chimpanzees and gorillas and their social behavior might be very similar to what Boisei and Robustus had at that point in time. So, at around 2.5 to 2 million years ago, we see in the fossil record the evolution of a new form. And historically speaking, at about this time, the Leakeys, well-known paleoanthropologists, digging in the Olduvai Gorge, digging in East Africa, as they were locating Australopithecus boisei remains, were also coming across a number of very primitive-looking stone tools that initially they thought were implements being used and manufactured by these Australopithecines. And so they searched high and low for clear evidence of direct association between the bones and the stone tools themselves. So the earliest stone tools were found in about the 1930s. It wasn't until the 1960s, excuse me, that they found the actual maker itself, him or herself. That would be this one right here. And because of the association of stone tools and direct evidence with the fossil remains themselves, the indication of this cultural advancement, the production of tools, the production of culture, suggested that to these folks at the time that we had something even more remarkable than this missing link, ape man. And so it deserved the genus name Homo, which of course we had already been named as Homo sapiens. And so they dubbed this first stone tool maker Homo habilis. Habilis refers to essentially handyman. You can see the word ability in the word habilis. And so being able to manufacture these stone tools to create a device that can access different aspects of your environment. For example, these simple chopping tools, this basic tool right here, taking another rock, knocking off a flake, and creating a simple sharp edge gives you so much more of an advantage over the other predators that are out there. Both of you are searching for meat. Before, you were probably, well, at this stage, you are of course a scavenger, probably trying to scare off the predators from their meal. Probably still scared to death of that lion that's out there who just took down the zebra. And so you're going to hang off until the lion's away from its kill. Who comes after the lion once he's had his fill or she's had her fill? Who comes next? The hyenas. Maybe you're brave enough to take on the hyenas. Maybe not. So you wait. Third phase, then come the vultures. and they take their fill. And so after all three of those phases, you're left with a carcass that has very little meat on it. But in order to get that little bit of meat off, you could probably grab some bones and take them back, or if you had a tool and were able to scrape off that meat, you could potentially take more with you. And so the suggestion is that these early tools were used for scavenging techniques to take the meat off of these kills, these animal kills. Looking at the fossil evidence of the bones, of the animal bones that are found associated with the stone tools, associated with the hominid skeletons, what do you call it? Microscopic analysis of the animal bones shows us some rather intriguing clues as to what these stone tools may have been used for and how. Looking at, say, a zebra carcass that was found at the time of Homo habilis some 2.5 million years ago, they've looked, you'll see tooth marks, scavenging marks across the bigger chunks of the body, the ribs, the pelvis, where the thicker chunks of meat are. And that would be, and microscopically, when you look at a tooth mark that's scraped across bone, it will leave a mark that's roughly square, like the image I'm trying to show you on the screen. However, other parts of the bones across the skeleton showed a different type of line or scratch. And this type of scratch was much more triangular, which is not represented in any type of tooth form of an animal that would be out there. Of course, you might think of hyenas puncturing bone, but they're going to leave a different traumatic defect on the bone. These scratch marks were found on animal bones with little bits of meat, like the face and lower limbs. A lion, a hyena, vultures, they're going to go in, get what they can, and take off, more or less. And so what's left, the meat that's left after those three phases of predation, are going to be probably little bits of tissue on the facial skeleton of the zebra, meat left on the lower limbs of these animals, and so in comes Homo habilis with its quick stone tools. Just a simple scraping tool scrapes the meat off and goes away. And this little bit of meat is going to be very crucial for brain development and evolutionary advancement. I'm skipping through a lot of extra stuff here, only because I don't know how much time this talk will take, and I want to leave time for some questions as well. Next species in line, essentially Homo erectus. Homo erectus takes a walk out of Africa with Homo habilis, eventually evolving into Homo erectus, who have large population sizes, theoretically, of Homo species evolving in Africa, accessing different lines of resource, manipulating their environments with these stone tools, becoming smarter, more keen, accessing resources enable them to eat more, bigger brain growth, more food, more health, more energy, more sex, more kids, more Homo habilis, more Homo erectus. And so as these populations start to explore, they start to move out, and you see the fossil evidence across the world, actually. The earliest Homo erectus that was found was in Indonesia, and I don't remember the year that it was found, early 1900s, I'll say, I think. But Homo erectus being found in Eastern Asia here, dating to, again, around 2 million years ago. We also find what initially was a Homo erectus species found in Africa as well, which has now been dubbed Homo ergaster. I've got that species up on the table here as well. So we have an African species living at around 2 million years ago. I didn't bring in the Asian species right there, but the Homo erectus living in Eastern Asia, cave sites, and we have this one right here, which was most recently found in Europe, Eastern Europe. Homo ergaster as well, a European species. We're now moving out of Africa. We have hominid species now out of Africa over in Asia and up in southern Europe. The Asian species are some of the interesting finds in respect to some of the cultural advancements that we see associated with these finds, is that in some of the cave sites, and it's questioned, it's doubted, it's debated, but in some of the cave sites associated with the Homo erecting finds, they find what could perhaps be simply described as hearths, or at least burned earth, suggesting that Homo erectus in Asia had the capacity for fire. And I make a point to say fire control, not fire making. There's no evidence in the fossil record or the archaeological record for that time that they were actually constructing fire, that they were making fire, you know, the rubbing two sticks together kind of thing. That doesn't necessarily mean they weren't, but the implication is that they were collecting it from nature. And of course, nature can produce fire in a variety of ways. I guess the best would probably be lightning blasting a tree, and with their smart hominid brains, they discover that if you put more wood on the fire, it will create a greater fire. And you know, we can go off with a number of scenarios here as to why fire became so much more relevant and important to Homo erectus life. But living in a cave, being a cold cave, fire would produce heat, enabling them to survive a little bit more comfortably in this cold, wet cave. Fire might have been also useful for scaring away the predator, the animal that lived in that cave. The cave bear, the cave lion, whatever animal you might think, scaring away the animal. Fire may have also been used to cook meat. I can almost picture a group of Homo erectines around the fire late at night, typically eating their raw meat, and one of theirs, you know, your chunk of meat that you're sharing drops into the fire, and you're like, oh crap, I don't have my meat anymore. You guys will get your meat. Come on, give me some of yours. I'm like, no, you dropped yours in the fire, man. Eat yourself. And so you grab a stick and you poke at it. I'm going to get my meat either way. And you eat that roasted meat that's been in the fire for a good 2 or 3 minutes now after you're discussing with your other Homo erecting friends. And you eat it, and you're like, wow, this tastes pretty good. This is good stuff. And you're like, haha. And then all your friends start throwing their meat into the fire. But from a health perspective, this could also be an adaptive advantage for potentially killing pathogens that might be in the raw meat, killing, I just talked about this in my other class about disease and larvae that grow in meat, and you know, you don't want to eat raw or undercooked meat because of certain pathogens that may be in it. So his family that happens to eat the cooked meat tends to live longer because they're living healthier lives versus those of us who die at somewhat of a younger age. So providing somewhat of an adaptive advantage for him cooking his meat. There are new theories that are coming out right now as to how fire and cooking contributed to some of this early human evolution. Furthermore, moving from the early Oldowan tool industry associated with Homo habilis, stone tools are starting to become more complex and more sophisticated as well. They're taking their time. They're creating a better tool. This is still not a point that is hafted to the end of a stick yet. We're still using tools that are in our hand, that are handheld devices. They describe this one as the Paleolithic Swiss Army knife. Swiss Army knife of the Paleolithic. This simple, no, try making one yourself. I've stood out in front of Panera waiting for my kids to come out. You know, in front of Panera they got that gravel out in front. And I sit there and I try banging 2 rocks together, and it's hard as hell. Granted, I'm not using the right rocks. But to try and make something like this takes ingenuity, takes sophistication, takes forethought. To pick up a chunk of rock and to see inside of it what you want to build takes a different way of thinking. But these guys had it. And they had this hand axe. And you can see the shape and the size of it in my hand. Other evidence that's coupled with these Homo erecting finds, especially in these cave sites, is littering the floor at this level, at this time level, are a bunch of crushed up animal bones. And these crushed up animal bones and looking more closely at the breaking points on these bones suggests that they were pounded, that they were cracked, they were broken open intentionally, not just kind of thrown off to the side and smashed somewhat unintentionally, but that these intentional breaking points, the fracture patterns on these long bones, suggest that these Homo erectines had the knowledge of what was inside of these bones. Let's go back to habilis, who's just scavenging. Coming out to this carcass of a zebra that's been scavenged by a lion, scavenged by a hyena, and scavenged by vultures. Habilis, just seeing these little flakes of flesh on the face and on the lower limbs, sure, it's a little bit of meat. Homo erectus coming to this carcass a little bit later, saying, ah, crap, we got here too late, all the good stuff's gone. Wait a minute, why don't we just take some of these long bones with us? Because I found that there's some stuff still inside the long bones that the animals aren't getting to. So I take the long bones back to my cave site, and I bash them with my Acheulean hand axe, crack them open, and there's some delicious stuff in there, at least to maybe Homo erectus. Well, to other cultures as well. That this bone marrow, this goopy mass of tissue inside the shaft of the long bone is chock full of vitamins and minerals and nutrients, also very essential to a growing hominid brain, enabling them access to a new resource. Evidence suggests that more than just meat resources, they were accessing these marrow resources as well. What am I doing? Further down the line, as Homo erectines continue to evolve, we've got Homo erectines in Africa, Homo erectines in Asia, Homo erectines in southern Europe. In Africa, at around 300,000 years ago, we've got some of the, maybe I should switch these actually. We've got the earliest find of a species that looks a lot more like us. Homo erectus, a fully erect biped. That's why they call it erectus, a fully erect biped, standing on two legs. Homo heidelbergensis, this form right here, much larger cranial capacity, larger facial features, heavy-duty brow ridge. And again, all these things that I'm throwing out, I know that there's a lot more information that should probably be said about each one of these and how do these traits evolve. And I'll just put in a plug that if you'd like more information, take my Human Origins class, offered every fall and every spring. But these features that they see on these early heidelbergensis forms, some suggest that the larger heavy-duty brow ridge, the robust cheekbones, and the heavy-duty jaw suggest that, well, not suggest, imply that it's strongly related to the type of diet that they had, that they used, no, excuse me, not so much diet, but that they used their mouth more as a tool. So using their dentition for what's described as non-masticatory uses. Mastication is the process of chewing. You chew your food, you masticate your food. But if you are using your teeth for other things, then we describe it as non-masticatory uses. I think we still all do this today. You're coming home with 2 bags of groceries and you still got to get your keys out of your pocket, so you put 1 bag of groceries in your teeth and you fumble around for your keys. Holding that bag of groceries in your mouth is putting a lot of stress on your jaw, a lot of stress on your teeth, certainly harming your dentition. And what we see in these guys back at this time, and the studies done with cranial growth and development and pressure put on the teeth, suggest that these guys were using their teeth as a clamp, as a pair of vice grips to hold on to things. What would they have been holding on to? Perhaps leather, perhaps hides to scrape with their stone tools to make clothing, because these guys are migrating out of Africa as well into southern Europe, over into Asia, into more cold weather climates, possibly a time period when clothing or some type of covering was starting to become more prevalent. The chewing forces, when you clamp onto something between your teeth, you're putting physical pressure downwards and you're putting physical pressure upwards. And if you're doing this as a cultural behavior throughout all of your life, theoretically, then you're going to put so much pressure on your face that those that can survive that type of pressure, those that can endure that type of pressure, would potentially evolve these types of facial features that could enable that, could absorb or allow the dissipation of those forces. And some paleoanthropologists suggest that these, I'll use this one instead, that those forces would have been emanating or dissipated up through the zygomatic arches and up into this heavy-duty brow ridge. So there's an absorptive factor, and then dissipated across the rest of the skull. Kind of a mechanical thing, and I'm not a physicist by any means, but the movement of those forces, and such that these large, heavier-duty brow ridges could have been an absorptive factor for some of these forces. But you don't want heavy-duty, thick bone in the front of your face, otherwise we'd be all walking around like this. And so if you look closer or inside that skeletal bone, you find it's described as what's called pneumatized. It's filled with these large sinus cavities. It's like trying to build a large structure that's not heavy. And so you fill it with all these rooms and cavities, like a beehive or something. So if you were to open up and cut open some of these larger skeletal features across the skull, you would find they're relatively hollow. And it's a combination, it's a physics kind of question, of being able to absorb that force, but still remain strong and light. And so this pneumatization of the skeletal features accommodates that. All right, now perhaps one of the hominids that you're perhaps more associated with, or more you see more, perhaps the more popular one, Neanderthals. I think that one's more in common parlance than some of the other species names. But Neanderthals, evolving roughly around 150,000 years ago, if not a little bit older. Evidence is coming out all the time, changing these dates. Neanderthals are a species of hominid only found in certain areas of the world. They're only found in Europe, and some of them are actually found in as far south as the Middle East and Eastern Europe. Existing for a relatively long period of time throughout most of Europe at this time. We're dealing with an ice age, so it's very cold. These folks are shorter than the average Homo sapien. They're stronger than the average Homo sapien, as evidenced by the strong cortical nature of their long bones. They're very well-muscled individuals. We can tell that by looking at the bony features on their skeleton. An adult individual reaches a maximum stature much shorter than the average Homo sapien today. They're shorter, they're stockier, they're well-muscled. This is evidence that shows us that they are very cold adapted, because we see this in other animal forms and other human forms that are cold adapted too. The large noses, as you see in the reconstruction in the middle here, some argue that, what is the name? I think they describe it as the register. Some type of register. What do you call those things that heat on the side of the apartment? Registers? Registers? Yeah, register. Radiator. No, radiator. Radiator hypothesis. Somehow implying that this human form living in such a cold weather climate, as you're sucking in this cold air, as we well know today how much it sucks. You go try doing this. You try to do what the Neanderthals did. Go outside and breathe through your nose. Our pitiful little pudgy nose sucks in this cold air, and we freeze our lungs off. And so you try breathing through your mouth because you've got a much wider cavity to breathe in this cold air. These guys, however, had a much larger nose in this radiator register, radiator hypothesis, whatever. The larger surface area inside a nose accommodates more mucosal tissue, more surface area inside the nose that's covered with snot. And this warm, moist snot will warm and moisten the air as it's traveling down into your lungs. Therefore, you're not sucking down as frigid air as you would in Northern Europe at 100,000 years ago. Well-adapted form for living in the cold. I've tried this, maybe for about 2 seconds, breathing through my nose as I'm walking across on the sidewalk. Do it yourself. It hurts. And, you know, they went extinct maybe for a reason. Maybe they, I don't know, we're all a bunch of mouth breathers, right? Some culture associated with Neanderthals. Now we got a different type of stone tool tradition. This one's called Mousterian. Again, more complex, more sophisticated in its nature. There are more types, different types of drills, different types of scrapers, etc. One key element of Neanderthal culture is they're the first ones to intentionally bury their dead. Habilis and Erectus and Gaster, you know, when Grandma and Grandpa died, you just left them on the trail back and you just kept on moving along. Neanderthals, however, living in these cave sites, rock shelters, we have found intentional burials of Neanderthal bodies, such that when Grandma and Grandpa died, you would dig a hole in the back of the cave, bury Grandma and Grandpa, and you know, other rather interesting information is that they have found a lot of flower pollen on tops of these graves as well. Bones laid in, flower pollen on top of the bones, and then dirt. So the archaeologist who's digging down through the dirt finds this gray or yellow dusty layer on top of the bones. They take a sample of it, send it back to the lab. Lab comes back and says, hey, guess what you have? You have a bunch of pollen on top of your Neanderthal bones. Cool, what does that mean? Well, put it together, 2 + 2, and many argue that at the time of death, they would have placed flowers on top of the grave. Now this moves into some rather cultural questions. Why would you put flowers on top of a grave? Why do we do it today? Well, some might say it's to add beauty to the disturbing scene of death. The forensic anthropologist in me says, well, maybe it's to keep the smell of the stinking corpse down. You know, the sweet-smelling flowers on top of stinking grandma's body, could be that way. Anyway, the fact that they're intentionally burying their dead is a rather unique cultural item associated with Neanderthals. Finally, there's clear evidence now that the anatomical modern Homo sapien form evolved first in Africa, roughly at around 150,000 years ago. Some would argue on those dates, but essentially at about this time we're finding the fossil evidence, clear fossil evidence, that the anatomically modern Homo sapien form, the form that is in every one of our skeletons today, evolved in Africa roughly at about this time, and has remained relatively unchanged for the last 150,000 years. Cultural remains associated with this species, our species. We've got art, we've got cave paintings across Europe, Africa, Australia. Jewelry, we've got shells and beads and whatnot. The Venus figurines, the two figures that are on the far left there, the middle one, the brown one, Venus of Willendorf, actually is not much bigger than about 2 or 3 inches tall. I can't remember if it's carved out of soapstone, one of them is, but it's a small carved figure. Some suggest that this might be a fertility figurine representing Mother Earth or the pregnant female as kind of like a totem, sympathetic magic, that if you carry this around it would guarantee health and fitness for the pregnant female, kind of like carrying around a rabbit's foot or a lucky charm. If you believe in it, it will happen. The cave paintings, other kind of sympathetic magic associated with that. Advanced stone tool industries as well. Neanderthals had points attached to the end of a spear. Modern Homo sapiens now have advanced the technology to using something called a spear thrower. Nothing more than a stick with a little hook at the end. They poke a hole in the end of their spear shaft, notch it, throw it, and this enables you to be further away from your prey, taking yourself out of the range of danger of being struck by a mammoth tusk or a saber-toothed tiger claw. So, tracking the quick route of modern Homo sapiens as they migrate out of Africa, earliest signs of modern Homo sapiens outside of Africa, 90,000 in the Middle East. You'd say, well, why didn't they go up into Europe at this time? Well, again, Europe's pretty cold and it's dominated by these big-nosed guys. 60,000, oh no, where's next? Australia around 50,000, 60,000 here, 40,000 there, migrate across the Bering Land Bridge just before the end of the last ice age, make it into North America. Earliest signs of modern humans entering into South America. I know there's some finds down in Chile dating to about 14,000, but roughly around 10 to 15,000 in South America. Real quick, 10 to 12,000 years ago, at this point, most changes in human evolution are more cultural and less biological per se. Slowly there's a move from exclusive hunting and gathering to settling down, a more sedentary lifestyle marked by the domestication of plants and animals. And I show a picture of the dog here. Evidence shows us that the dog was the first domesticated animal at around 11, 15, 20,000 years ago, depending on who you want to talk to. Growing our own crops, tending our own animals leads to a stable food supply, eventually to some of the bigger problems: population growth, urbanization, McDonald's, Jerry Springer, all that good stuff. So, this is my birthday present to Chuck. So, happy birthday, Chuck. There you go, the end.
We have time for 1 or 2 questions. And I've got the microphone here, so I think you had your kind of first opportunity.
We have some differences in interpretation, let's say.
I suspect you do.
There are a lot of species that you did not include in your scenario. There's some 20.
I'm limited to 45 minutes, too.
Species. But that leads to an implied linearity of this led to this, led to this, led to this, which I think is a very misleading view. The cartoon at the top has that same implied linearity, human evolution was incredibly bushy. And we really don't know if, for example, afarensis is ancestral or not. I also, finding stone tools at Olduvai, along with Paranthropus, studies have shown that they could in fact hold and use stone tools. I'm very wary of, until we find Homo habilis actually holding a rock, very wary of attributing things like that to a particular species. I think some of the scenarios are overdone, put it that way.
Okay. I agree with you a lot, and I think my simplest response is because I was limited to such a long period. I mean, I teach a whole class about this kind of stuff too, and although some of that linearity comes out perhaps in my discussion throughout my class of human origins, I also incorporate the basic evolutionary theory that you're discussing, the bushy evolution, etc. Limited of such a short period of time, and understanding that I was just here to kind of present the fossil record more than describe and detail the fossil record, showing that there were fossils out, hominids out there that were using stone tools at a certain time. And yes, finding a Homo habilis with a stone tool in its hand dead in the dirt is going to be a tough find, let alone finding a Homo habilis in the first place. That Australopithecines were not stone tool users, hard to say. In fact, Leakey suggested in the earlier days. Chimps are stone tool users. They will use hammerstones to suggest that Australopithecines may have manufactured stone tools. That's a question. That they could have seen Homo habilis using stone tools and copied them themselves and used the remnants of the stone tools to crack open bones or whatever. There's just so many questions out there.
Or vice versa.
Indeed, right. And so, and I will simply respond also that I am not a paleoanthropologist. I am not up 100% on all this data. And so the problem with my interpretation is that next year it's going to change. It's changed last year. And so to keep up with the times, and one year it's Homo erectus, one year it's Homo ergaster, you've got some problems. And the interpretations that are made, I'm not making those interpretations. I'm just kind of showing you what's out there now. Okay, am I making my own interpretation? Yes, I guess I am. You could argue that. Is there another question?
Yeah, sorry, I was having trouble with the mic. We actually don't have time for that last question. I'm really sorry, but I just have a couple things to remind you of before we